Let's go ahead and convert a standard form linear equation over to slope-intercept form. And as we do that, the first thing we want to do is write down, well, what is slope-intercept form? If you remember, that is y equals to mx plus b, where m is our slope and b is our y-intercept. All right, so when we do this, I'm going to start with the do-undo table. I'm going to go ahead and say that we have our do's, and then we have our undos. And what we're going to be thinking about is the relationship to y. We are solving for y. So I'm going to start here and say, what is happening to y? Well, as soon as we have y, we are going to multiply y by 2. And then after we multiply by the value of 2, we're adding 8x to it. So I'm going to put 8x to it. And then if that happens, after we add that 8x to it, our answer should equal this value of 2. So that is what is occurring in the mathematical process. So we are starting with y, multiplying by 2, adding 8x, and that is equal to the value of 2. Now, what if we undo those steps? So we start with 2, and let's undo those steps. Instead of positive 8x, we're going to be subtracting 8x. Instead of multiplying by 2, we're going to be dividing by 2. And what that should do is get us to what 8y is equal to. So we've undone all those operations. Well, let's go ahead and write that out. Y equals 2. We start with 2. We subtract the 8x. We start with 2. We subtract the 8x, and then we divide everything by 2. So we divide everything by 2. And that will tell us what y is equal to. Now, we can clean this up a little bit. We can actually say, well, y is equal to 2 over 2 minus 8x over 2. And that is 2 divided by 2, which is 1, and minus 8 divided by 2, which is minus 4x. So what we end up is saying is we have y equals to 1 minus 4x. Now, that's not exactly slope-intercept in its perfect form because we like to put the slope and the slope and the x first. So I'm just going to go ahead and change the order. I'm going to say y equals to negative 4x plus 1. That is a positive 1. Now, we just did this using a do-undo table. Of course, you can do this algebraically as well, and some of you have seen that before. So I'm going to do that as well. We get rid of that positive 8x. A lot of people would recognize it of saying, hey, we get rid of that positive 8x with a negative 8x. So I just subtract the 8x over. 2y comes down, we get 2 minus 8x. And notice what happens, we end up in the exact same spot. 2 is attached by multiplication, so we reverse that order and divide everything by 2. And y equals to 2 divided by 2, which is 1, negative 8 divided by 2, which is minus 4 with an x. However, the original do-undo table kind of explains why you end up with that 1 minus 4x. Now, the one thing we do want to do is we want to answer a couple things out of here. So what is the slope? Well, the slope is attached to x. That's at negative 4. What is the y-intercept? The y-intercept is this value out here, positive 1. And of course, what is our slope-intercept form? Y equals to negative 4x plus 1. Now, I know I've written a lot of answers down, but we're not going to be able to do this unless we're 100% correct. So what I'm going to do is I'm going to go to MattDoesMath. I'm going to type in the original answer, 8x plus 2y equals to 2. And you'll notice that that graph lines up. And all we've done is converted the form. So if we convert the form, the answers should be exactly the same. So now I'm going to type in the 1 minus 4x with a negative 4x plus 1. So let's go to MattDoesMath and type in y equals negative 4x. 1. Now check out what happens. They are exactly the same. So they overlapped. So they were overlapped. And because that means they are the same. But they are in different forms. And so that means that we have actually converted from standard to slope-intercept. All right, I hope that helps y'all understand the process of going from a standard form linear equation to a slope intercept y equals mx plus b equation, and you are able to not only make that conversion, but understand the parts of that equation. All right, y'all have a great day.